So, I had an idea about making 3D printer filament from recycled soda bottles. Lately, I've been watching a bunch of videos by Slant 3D, and I've been following their endeavor to start selling PLA 3D printer filament at $10 per kilogram, but doing it without cutting corners on quality or just outsourcing everything to overseas slave labor camps. It's really interesting to see the engineering challenges they're encountering using the current manufacturing methods. Conventionally, filament is extruded from pellets using a screw-type extruder like you'd see in injection molding. The stream from this extruder is subsequently dipped in water to cool it down. It's dried, it's fed onto a take-up roller that speed is controlled, and then it's spooled up. The control of this process is more or less down to the speed of the take-up roller. Pulling the extrude faster will thin it out, while as pulling it up slower will make the filament thicker. While simple, this method is reported to be finicky, requiring close monitoring, and requiring predictive control, which is non-trivial to get working. I've seen many home, hobbyist, amateur products sold that use this process, been covered on various other YouTube channels. And even though they're considerably expensive, and they're still reviewed as being fickle and unreliable, especially when you start trying to recycle plastic with them. Recycling plastic has its own myriad of frustrations, which I propose exacerbates the technical challenges posed by filament extrusion by itself. Things like inconsistent flake size when you get shredded plastic leads to inconsistent extrusion, which adds a layer of unpredictability to the predictive process control that is required to get precise filament out of a basic extrusion system. There is, however, a process for recycled plastic filament, which has made the rounds in the DIY community, which is simultaneously a more jerry-rigged looking solution, but it's also more often praised for printing well. The process involves using a jig to cut the cylindrical portion out of a soda bottle into thin strips, which are subsequently rolled into a tubular shape and then spooled like regular filament. The process is extremely labor intensive. Each bottle must be prepared to fit into the jig, the bottom needs to be cut off, and the short lengths of filament that you make must be manually spliced together because one bottle only produces a few meters of filament. And in addition, it doesn't make use of the neck or the bottom of the bottle, which, by the way, is where most of the plastic in a typical soda bottle actually is. But the filament that results from this is apparently pretty performant. So I came up with an idea, a hybrid approach that hopefully could be scalable and maybe even better suitable to recycling. I hypothesize that the reliability of that turned bottle filament is the result of the cutting process providing an extremely consistent volume per linear length by virtue of cutting a rectangular cross section from cold plastic, as opposed to trying to walk the tightrope balancing fluid dynamics, temperatures, extrusion rates, and the speed of the outfeed roller to try and get a consistent round diameter out of a conventional extrusion system. Based on this, I propose a process to produce filament from fresh plastic pellets and recycled flake in any proportion. To begin, the process is the same as with conventional filament extrusion. We have a hopper with pellets and flake, feeding an extrusion screw and die as drawn here. I suppose the extrude form would work fine as a round cross section, just like normal, but I think an oval would work better, be easier to feed. But where this differs from the typical filament manufacture is that the hot plastic is fed onto a chilled metal roller instead of into a water bath. This chilled metal roller then meets another roller, which is held a fixed distance away, and it smooshes the extruded plastic to a tightly constrained thickness. And any variability in the extrusion rate, or take-up speed, or whatever, will become a variance in the width of the plastic ribbon. Partially cooled plastic would then go over another roller, and this roller meets two blades. I've drawn them here kind of like saw blades, but I kind of imagine them more like pizza cutter or can opener blades. These would cut off both of the irregular sides of the ribbon, constraining it to an easily controlled width just by adjusting the distance between those blades. And finally, the ribbon is rolled and pultruded to a usable filament form factor and spooled, just like the bottle recycling method. The offcuts are chopped up and then fed back into the extruder so that we don't have a lot of waste. How well would this actually work? I don't know. I had this idea and I thought I'd share. I'm drowning in projects right now, so I don't think I can really build this thing right now, but if somebody else does, hey, if you think this idea is stupid, or if you want to know more, you want to try it out or whatever, tell me about it. I want to learn me something, and it boosts engagement. So, thanks y'all for lending me your ears for just a few minutes here, and stay tuned for more mechanical shenanigans like these.